Okay, second part of our conditional probability. Just to remind you guys that the probability of A given B is the probability of A and B over the probability of B. So this is the conditional probability, which is A given B. And also I can use my algebra, I can multiply that by that and say, okay, the probability of A given B multiply by the probability of B is equal to probability of A and B. So one can use that from that formula. Okay, now let's focus on an example 2. Example 2, guys, there's that I'll be using. Remember, when you do your probability, I'll really advise you to draw your tree diagram or your Venn diagram, but that's not really necessary, okay, to do that. Now, let's focus here. A certain medical disease occurs in 1% of the population. 1% of the population. After a screening process, it is seen that in 8 out of 10 cases, when the patient has a disease, it produces a positive result. Okay, let me highlight that. If the patient does not have a disease, there is still a 0.05 chance that the test will be positive. Okay, so what we have to do is find the probability that a random selected person does not have a disease but gives a positive result in screening. Okay, can you see that? And the second one gives a positive result on the test. Lastly, if Liam has taken the test and the result is positive, find the probability that he has a disease. Okay, so let's complete our tree diagram first. Before I do that, guys, you have to, if you introduce variables, you have to define your variables. Very, very important in the mathematics community. Okay, and let's see, represent the patient with disease. So implies here we have a patient with disease, and here a patient without that disease, okay, which is C prime. As a screening test gives a positive result, so if you have a disease, it might give positive results, negative results also there. On here also positive results and some negative result. Beautiful. Now, a certain, let's go back, a certain medical disease occurs in 1% of the population. So here we'll have our 0.01% of the population. But what we have to remember is that that branch plus that add up to 1. So we'll have 0.99. Okay. So let's look at after the screening. After a screening process, it is seen that 8 out of 10 cases, when the patient has a disease, it produces a positive result. So 8 out of 10 implies 0.8 there, and we'll have 0.2 there. Okay? Positive results, then we might have some negative results also. Okay? If the patient does not have the disease, there is 0.05 chance that the test will be positive. So the 0.05 chance that the test will be positive, so which is 0.05 that is positive, and that is not positive, which we can have 0.95. Just remember that that plus that add up to 1. Beautiful. There I have my tree diagram. I can start answering my questions. The first question, Okay, let's start with the first question there. Okay, find the probability. Okay, let's see there. Find the probability that a random selected person does not have a disease but gives a positive result in screening. Okay, does not have a disease but give a positive result in screening. So does not have a disease there, can you see that branch, but gives a positive result in screening. Okay, so what is this? Is the probability of not C multiplied by the probability of S. And if we do that, what do we get? Is that 0.99 multiplied by 0.05, and we get 0.0495. Beautiful. Okay, second one. Now, we look at the second one. Find the probability that a random selected person gives a positive result on a test. What is the probability of positive result on a test? So a positive result on the test, guys, what we have to do here is, to get a positive result is, that branch to there. Do we have something else? Yes, positive result, I can be probability of not getting a disease, but if I go for screening, I can get a positive result. Can you see, guys? So what is this? It's the probability of C multiplied by the probability of S. Okay, what am I doing here? It's the probability of C, okay, multiplied by the probability of S there, plus the probability of not having a disease, but multiply, if I screen, there's a chance that it will be positive, which is probability of S, that and that. So the probability of C, which is 0.01 multiplied by S, which is 0.8, plus not C, which is 0.99 multiplied by P S, that side, which is 0.05, and if I put this on my calculator, I get 0.0575. Okay, beautiful. The last one. If Liam has taken the test and the result is positive, find the probability that he has a disease. So here is our conditional probability, guys. So we want this, number 3. Okay? And I'll encourage you guys as you work on this and you have your worksheet in front of you. Okay? So this is the probability of C given S. So which this is equal to the probability of C and S over the probability of S. Now, the probability of C and S, remember, C is the probability that a patient with a disease, and S, the probability that screening is positive. Okay, so what is that? C and the probability that the screening is positive. C and the screening positive. You can see that, which is 0.01 multiplied by 0.08. 0.01 multiplied by 0.08. 6.8. Multiply by 0.0, and what happened there is 0.08 over what? PS. And PS is the probability that a screening will give a positive result. So, and we have done this, which is number 2, and it gives a positive result, which is there. Okay, over 0.0575, and if you put this on your calculator, you should get 0.139. Beautiful. So now, guys, what I'll encourage you from here, you do the exercise. I have problems after this on conditional probability, and with full solutions you do this, and if you have questions you can really ask me. Okay, and good luck with your studies.